All right, so now that we've seen our examples with our discs and our washers, I'm going to come back and kind of show you some examples of some radius changes. So instead of just rotating around the y-axis or the x-axis, what happens if we're rotating around a given line? We're still going to be dealing with horizontal lines and vertical lines, but not exactly the axes, okay? So I'm just going to set these up. I assume that you know how to anti-drive at this point and you can simplify them. So we're just looking at the setup today to determine what our radii are going to be, okay? So I've got our example set up here, and we're going to take this and we're going to rotate it around 4 different lines and how that changes the radius of our circles. So first one we're going to rotate is around the line y equals 2. So what happens is we're actually going to be rotating up and above a line here, okay? So just for, I guess, a visual, I'll go ahead and say our line is somewhere up here, like this, all right? So now when I'm looking, we're still rotating. It's going to complete, or what word? Create. That's the word I wanted. It's going to create a washer. So all of these are going to be washers because we're going to have gaps. So I'm looking for my outside radius, and based off of this line, my outside radius is going to be my x squared, okay? But this is actually the length that the x squared gives me, but the radius is above my function. So the radius for that outside function, it's actually going to be 2 minus the x squared. The full distance is 2, but I'm going to take away this little piece and leave me with that radius. So this is my radius squared minus, then that inside radius, whoops, I went to the outside again. The inside radius is going to be my square root, but again, it's the difference between 2 and the square root of x. So I'm going to do 2 minus the square root of x squared. And then if I set this up, this is going from 0 to 1, and then I give it a little bit of depth, dx. That's all it is it's just trying to determine what that radius length is. Then you just plug it into the formula. We've seen that set up, and then we're going to anti-drive and solve. With this one, it's going to be a little bit trickier because you're actually going to have to FOIL each one of these out, combine like terms to make it easier, and then anti-drive, just to make your life easier. There's a little bit of algebra work, but you can do it. Okay, so the next one is we're actually going to rotate around a line that's now below the x-axis. So what's happening here is my outside radius, my function x squared is here, and then I'm adding this distance of 1. So that outside radius is going to be x squared plus 1. And then the inside radius, oh, I flipped that, sorry. That outside is actually the square root. Yep, that upper curve is the square root. So that's going to be the square root of x plus 1. And then the inside radius is the x squared plus 1. So since we're now below the graph, the x-axis, we're actually increasing that radius length by 1 unit. So we just take our function plus 1, and that's our radius. And I'm still going from 0 to 1, pi, and give it a little depth, dx. Okay? All right, so what happens when we do the y? The thing is, it's going to behave the exact same way, but we're going to be in terms of y instead of x. Okay? So if we go ahead and make our conversions, this function is now going to be the square root of y, and this function is actually going to be y squared. Okay? So if we rotate around x equals 1, that's this line here. And again, your radius is now from 1 to the function. There's the inside, there's the outside. Our function is given this. So we're going to find the difference between our radius and the line of rotation. So my outside is actually going to be the y squared. So I'm going to have 1 minus y squared. And then the inside is the square root. So that's going to be 1 minus the square root of y. Give it a little depth. And we're still going from 0 to 1. Our bounds stayed the same for x and y, so that's kind of nice. Okay? Hopefully that makes sense. All right. So we got one more. What happens if we rotate around x equals -1? All we're doing here is adding distance to our radius. So there's our inside, and here's our outside. So the outside is our square root of y. So the square root of y, we're going to add 1 to that. And then our inside is the y squared. We're going to add 1 to that. Give it some depth. Add them up from 0 to 1. Times them by pi. Again, there's going to be some foiling in all of these to simplify them before we anti-derive. But I believe in you. You can do this. Good luck.